Here's the problem. A baby is born in a hospital on Earth, but for some unknown reason, the baby is stationary relative to the heliocentric reference frame, so it doesn't move with Earth as it orbits the sun. The baby thus crashes out of the window and hurtles off into space. Don't worry, the baby is indestructible. The question is then, by the time that the Earth completes one orbit and returns to the baby, will the parents be early, late, or exactly on time for the baby's first birthday? Let me know your answers in the comments before I get into the solution. And thanks to my fellow TAs who helped come up with this question. This is secretly a twin paradox problem. From special relativity, depending on your relative path through spacetime, your elapsed proper time, the time that you yourself experience, may be different. This is because moving through space relative to an observer transforms how much you move through time. So what we need to do is integrate the proper time interval that an observer on Earth accumulates over one revolution, relative to the stationary baby. We find that by the time the Earth returns to the baby, it has experienced 156 milliseconds less time than the baby, and thus arrives late to the birthday. But that's not all. Being next to large masses also makes your clock tick slower due to gravitational time dilation. So the parents on Earth, being close to Earth, also experience a little less time, another 22 milliseconds. So the parents are late to the birthday by about 178 milliseconds. This would be the end of the story if not for some astronomy. You see, our calendar year is 365 days, but our sidereal year, the time it takes for Earth to return to the same position in its orbit relative to the distant stars, is actually about 6 hours longer. That's why we have leap years. Every 4 years, we are one day in debt. So then the parents are late by a whole 6 hours. Unless, of course, it was a leap year, in which case the parents will be early by about 18 hours.